Welcome to our series on solving trigonometric equations. Let us understand how do we solve equations involving double angles. Thank you. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we are taking very interesting trigonometric equation. It involves double angle for both cosine and sine. Now, there are many questions related to these, and I hope the solution of this particular video will help you understand and solve similar questions. Those of you who want to learn directly from me, feel free to send an email on globalmathinstitute@gmail.com. Our students are right there on the top getting awards and scholarships. Now let us see how do we solve this particular question. Part A is consider f of x equals to cos 2x plus cos x plus 1. Solve for f of x equals to 0, where x is between 0 and pi. And B is g of x is sine 2x plus sine x. Solve g of x equals to 0, where x is between 0 and pi. And C is find points of intersection of the two functions. So let's begin with 6a, which is we are given cos 2x plus cos x plus 1 will equate it to 0, finding solution of this particular equation. So double angle formula, as you know, cos 2x can be written as 2 cos square x minus 1. So we are going to write cos 2x as 2 cos square x minus 1 plus cos x plus 1 equals to 0. So that gives you 2 cos square x plus cos x equals to 0. Plus and minus 1 cancel. You can factor out cos x now. So you get 2 cos x plus 1 equals to 0. So that basically gives you two different solutions. One, we're looking for cos x equals to 0, and the interval is between 0 and pi, right? So within this interval of 0 and pi, we get x equals to pi by 2. That is the only solution for the first part. And the second part is we have 2 cos x plus 1 equals to 0, means cos x equals to minus half. So that means we are looking for solution in quadrant 2, right? You can also draw a special triangle to get the exact value, right? So cos x half means adjacent to hypotenuse. The angle is pi by 3. So this angle being pi by 3 means in quadrant 2 it is 2 pi by 3. So we have this value of x as 2 pi by 3, correct? So we have two solutions for part A, one being pi by 2, the other one 2 pi by 3. Perfect. So I hope the steps are absolutely clear. Now, on a fresh page, let us see the solution for 6b. Right. So we are now solving the equation sine 2x plus sine x equals to 0. Sine 2x, the double angle formula is what? It is 2 sine x cos x, correct? So we'll replace that and we can rewrite this as 2 sine x cos x plus sine x equals to 0. Sine x is common. 2 cos x plus 1 equals to 0. So again, we are now looking for solutions for sine x equals to 0 and cos x equals to minus half, right? So when is sine x 0? We are working in the domain 0 to pi. Perfect. So within this domain of 0 to pi, we know sine x equals to 0 implies that x is equal to either 0 or it is pi by 2, or pi, correct? For 0 and pi, sine x is 0. Now cos x equals to minus half. We just worked out that it has to be in quadrant 2 and the angle being 2 pi by 3, correct? So we know this is x equals to 2 pi by 3. So now you can see that when we are looking into part A and B, we got x equals to 2 pi by 3 for cos x equals to minus half as a common solution. So for part C, find the points of intersection of two functions means f of x equals to g of x. The only angle is 2 pi by 3 within the given domain of 0 to pi. Clear? So that is how we can actually solve this particular question. I hope it makes sense. So basically, what we did here was, as we can recall, important things to remember is the formula basically. So we know cos 2x can be written as 2 cos square x minus 1. Sin 2x was written as 2 sin x cos x. And after factoring, we found that both are true for cos x equals to minus half, which was minus pi by 3. Perfect. So that is how we are going to solve it. I hope it makes sense. Feel free to write your comment, share your views. If you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.